All right, hello everybody. So, as I expected, low attendance today, but what we'll do is I want to finish off something, the discussion on the conceptual database design today, and then I'll introduce logical design, but due to a couple of factors, one being that there's so few here live today, but then also because of the midterm coming up next week, I don't want to pollute the waters, right? I don't want to give you too much new information right now, right before the midterm exam, because really the whole conceptual database design, logical database design specifics that we've been talking about yesterday and then today won't be on the midterm. This is new information that will show up on the final, so you need to know it, but at the same time, you don't need to know it for this next week. And so I don't want to do too much of polluting the waters here. Okay. All right. So let me go ahead and share. Where are you? There you are. Okay, so I'm going to go ahead and share this. And what we'll do is I'll go back to the redundant relationships, things we were talking about. Okay, so we talked about this where we have a redundant relationship. And in this situation, the redundant relationship is this idea of the rents relationship, right? And so the reason why we would call this a redundant relationship is that if a client holds a lease, that means this lease represents them renting an apartment or a property. And so the client will hold a lease, can hold many leases, right? And that lease is associated with a property that the client is renting. Now notice that the client can hold many leases, meaning they can rent multiple properties over time. You know, if you've ever stayed at an Airbnb or if you've ever rented a hotel room or something like that, then you know that just because you've rented one place off of Airbnb or you've rented one hotel room off of, Tatil Budur or something like that, doesn't mean that you can't use that service again, right? You can always rent another place, another hotel room, another Airbnb, right? And in the same way that just because a property has been rented one time doesn't mean it can't be rented more than once, right? It can be rented by different people. If you really like an Airbnb property, you can rent the same Airbnb property more than once, right? So this lease, though, is a record of a client who leased a property, who rented a property. So we don't need to have another relationship called rents here. Okay. But then we also said, and I asked you to think about kind of a take-home assignment, not assignment, not like a graded assignment, but a take-home thought assignment, is this would be an example of a non-redundant relationship. Now, it might look like it, if you have, like in my family, right? I am married to a woman and we have children, right? And the children are, I'm their father and she's their mother, right? But that doesn't mean that that's always true, right? You could have, so some examples was, what if a man and a woman have children and they get divorced, right? Or they never got married in the first place, or something like that. Or you could have a man who's married to a woman and she is the mother of a child, but he's not the father, where you have like a second marriage or something like that. So there's all kinds of possibilities where just because we have this relationship and this relationship does not mean that this represents the same relationship as married to. Okay, so that's an example of where you have a non-redundant relationship. Okay, so one of the examples that I said I would show you, and what I'm going to do here is I'm going to actually share here. So this should work. Okay. Okay. So what I said was I would show you another example. Let me change the color here. Okay. Where, what if we had the situation where, okay, what if we had the situation where you have an entity called what can we call it? What was it? A department, right? So you have, or faculty. No, department. Let's call it department. So like the computer engineering department, right? And actually, I shouldn't show it as an arrow. That's not right. And the department has many staff, teachers, something like that, right? Okay. Actually, just teacher. I always do singular, not plural. And a teacher must belong to one and only one department. And let's assume, just for a simplistic example, a teacher teaches course. Okay, now a teacher can teach between, let's say that we say between 1 and 4 courses. Let's say this is representing a semester, and a course must be taught by one and only one teacher. Now, obviously, there's in a real world university system, there would be some other finer ways to do this, right? And let's say we wanted to say, oh, but you know what? We want to have that a department. So let's see. We'll say this is the employees relationship. So they employ teachers. Teacher teaches courses. And let's say department offers courses. Department offers one to many courses. And a course is offered by one and only one department. Okay. Now, in this example, this would be a redundant relationship, assuming that the teacher can only teach courses in the department they're a part of. So in other words, we would not have, let's say in this example, in this particular system we're setting up, we have a restriction that I would not be allowed to teach the Turkish class because that's not in my department. The Turkish class is in the Turkish. Believe me, I should not be teaching the Turkish class. Okay, I know a little, right? But I know enough. But I'm not about to try to teach the Turkish class. Right? I also should not teach the history class. I do not know enough about the principles of Mustafa Kemal Ataturk enough to teach the history class. Right? So I teach courses in the computer engineering department, in the CSE department. All right. So let's assume that in this example I'm giving you that we put this requirement that teachers can only teach courses in the department that they're a part of. The teacher and the course must match departments. Okay. So what that means is, in order to discover what department a course is in the way that I've drawn this, to discover what what department a course is in, we could either go through the teacher and say, okay, for a particular course, who's teaching it and what department are they in? Okay, you should know how to do that through an SQL statement. All right, that should already be something you should know how to do, how to discover what department a course is in based on who's teaching it. If we had this system like this, we could also go through here, all right, and find out what department course is in there. But the problem is, and here's where the problem comes in. this is why the redundant relationship is a problem, is if we set up our system this way, there will be a foreign key column to teacher. There will also be a foreign key column to course, or sorry, to department, right? Multiple columns. And we will have to do things in our system that make sure that the data is consistent, that we don't have a teacher in the CSE department that is for a course that is in a different department, right? We would have to do a lot of extra work to make sure that that happens. So what we could do instead, I'm going to back out of this a little bit. What we could do instead is just remove okay, whatever. Is just remove this relationship. Now, again, this is another example of something I've said before, where I've said it may seem counterintuitive. It may seem like, but Hojam, isn't it harder to go through the teacher? Like, isn't this hard? Like, we have to go through the teacher to find out what the department. Wouldn't this be a lot easier for us to just have in the course what department it's in? All right. For us as humans, yes, it would be easier for us to just keep it right there, for us to find it quickly. For a computer system, there is no lag. There's no substantial difference time-wise. We're talking about milliseconds, right? We're talking about microseconds in time, right? The difference between going through the teacher entity to find out what department a course is in, okay? But what we gain is that this methodology, going through the teacher to find out the department, what that does is that maintains data consistency a lot better. Okay. Now, this is all dependent. This is all dependent on us requiring that a teacher teaches a course in the same department that they are in. If we allow, like, let's say for example, I was allowed to teach the math course. Maybe I'm allowed to teach calculus, but it's in the math department, but I'm employed by the CSE department. If we allow that, then we do need this other relationship. Okay. There's another situation where we might need this relationship. Okay? And that is if instead of, let's see, course, if we had this, okay, a 0 there. If we were to say that a course is not required to be taught by a teacher, that maybe there's just not a teacher assigned yet, right? If we allow that foreign key column I talked about, the foreign key to the teacher table, to the teacher entity, to be null, so we have a course that's not taught, well, then we need to know if it's not taught by a teacher, how do we find out what department it's in? Now suddenly we do need this, right? And I hope you remember what this is called. If this, right, if this situation were here where we have a department has teachers, a teacher teaches courses, but a course is not required to be taught by a teacher, how do we discover what department a course is in, right? Then how do we discover that? We can't. This is a type of trap, right? We call this a trap. Make sure, now this whole trap concept, the different types of trap, the fan trap and the chasm trap, right? Which one this is, you would need to know that for this upcoming midterm, okay? I can guarantee you there will be a question regarding fan traps and chasm traps on this midterm. All right. So make sure you know which one this is. All right. So that's some examples of redundant relationships and how to make sure we know the difference between a redundant relationship versus a trap that we are trying to overcome. Okay. Sometimes, because they look similar, right? They look similar, and we have to be cautious. We have to be careful that we don't cause a redundant relationship to fix a trap that's not there. We also need to be cautious not to remove a redundant relationship and end up inadvertent. Sorry, we need to make sure that we don't remove something we think is a redundant relationship and inadvertently cause a trap. Okay? All right. Let me get out of here. And that should be. It's not. Let's see. It's not sharing that screen back again. Let's go ahead and pull back and try that again. There we go. That's better. All right. And then finally, one thing we didn't get to yesterday, but I'd like to go ahead and just at least briefly mention is that one of the final things we do before showing our customer or our user our entity relationship diagram is go ahead and check transactions that a user will use our system for, to make sure that, and these are all noted in the textbook. This A, B, C, and all these different pathways are noted in the text. And just make sure that all of these different transactions that the user might use are supported, right? So we should have some pathway, right? Some transaction that justifies that why we have all these different entities and relationships, and make sure that every transaction that's in our list is covered in some way in our diagram. Okay. All right. So that's the conceptual database design. So that's conceptual. Okay. So remember what I said was for each phase, the conceptual phase, the logical phase, the physical phase, the output of one will kind of serve as the input to the next phase. So the output of the conceptual database design was an entity relationship diagram. So once we have a final ER diagram that's signed off by the user that represents the portion of this, it doesn't necessarily have to represent the entire system. It needs to represent the portion that we were tasked with designing. Okay. So, for example, I might be tasked with designing the student views, the student side of our university system. In which case, I don't need to have information. I need to have information about students. I need to have information about courses that they are taking. I need to have information about what department they are in. But I probably don't need to have a lot of specific information about the instructors. Right? I don't need to know. In order to design the student side of things, I don't need to know the instructor's birth date, right? I might need to know what department an instructor is in, but probably not even that, right? There's not really a whole lot of things that I need to know about the instructor side of things at all to design the student portion of our database, right? So I might have very little, if any, information about other parts of the database that I'm not responsible for, okay? But the output is going to be an ER diagram that represents the portion of the system I'm designing. Okay, and one of the final steps in the logical design is to merge them into, so here we can see this, is to merge our portion of the system that we've designed with other portions of the system that other teams have designed. Obviously, if we are in charge of the entire system, if it's a smaller system such as maybe what you're designing for your group project, or even to some degree a university system that I'm saying, okay, I want the instructor, student, and course information. I might be in charge of the entire system, or I'm sorry, my team might be in charge of the entire system, and so we might have, one ER diagram that represents the entire thing as the output of the conceptual phase. That's possible. Okay, so this merging phase, this merging step, sorry, I'm on the wrong screen. This merging step is an optional step because we may not be required to do it. Okay, so I'm going to kind of introduce the a bird's eye view of a few things because it's kind of a limited day, and again, you guys are all not real focused on this stuff. You're really just wanting to do well on your exams. I'm not going to get into the weeds of this, but as soon as the midterm's over, we will. Okay, we're going to get really hard. We're going to drill down into this pretty deep once the once the midterms are over. Okay, so one of the things that we're going to do is we're going to derive relations. Okay, so here we've had these entities. Remember, these are entities in an ER model. They do not represent relations on their own. All right. Some of these will become relations, tables. Right? Remember, relations and tables are kind of synonymous. They're kind of the same thing, but entities don't necessarily mean tables. Some of them absolutely will be tables, but not all. Sometimes two entities together will be one table. Sometimes one entity will be more than one table. Sometimes a relationship will become its own table. Okay, so sometimes we have like a situation here where these three entities might represent one table, might represent two tables, might represent three tables, might represent four tables. Right? So there's all kinds of possible ways that this can end up being realized into a logical data model. So we'll talk about how to understand the different entity types and how to do the different relationships and how different types of relationships will become tables in their own right. Okay, so that's how we derive relations. We'll talk about that again. I'm just giving you kind of a bird's eye view, and we'll get so that deriving relations and how to make relations is a big step in this. So it takes a long time. So you see, as I'm kind of quickly going through these, all of that was just step 2.1, and we're already halfway through the slides here. Okay. Once we've created our relations based on our ER model, we need to go ahead and do the process of normalization. Hopefully, most of these relations, these tables, are already fairly normalized based on our ER model, but that's not always the case. So we do want to go ahead and look at our different relations to make sure that they are normalized. Again, we will validate our relations now against our user transactions. So remember, we did that with our ER model, but now we're going to do that with our logical model. Okay, we're going to make sure that our relations work well with our different user transactions. We're going to check our integrity constraints. All right. We're going to make sure that all kinds of different things are represented, like what's required, what can be null and what can't. Are we making sure that foreign keys are identified, that kind of stuff. Okay. So notice here, this is kind of one of the outputs, this logical model. This is kind of the output of the logical design phase. Notice this is getting closer to SQL. This is not SQL yet, right? You cannot run this in MySQL or in an Oracle interface, right, and get a table. But it is getting closer, right? So we're getting away from a visual representation and more of a thing that we could use to create these tables later. Okay. So we are getting closer. We're having table name and column names and what's the primary key and what are the foreign keys that we need to define. Right, so we're getting closer to SQL. We're not there yet, but we'll get there. Again, we need to review. Now this is different from validating the transactions. Remember, the transactions are our list of ways that our user expects to primarily use our system. We've validated our model using those transactions, but now we need to go to the user and see, hey, does this accurately represent the requirements of our system? The optional step of merging, we'll talk about that in more detail in 2 weeks. And so once we merge them into a global model, all right, we'll do that. And we validate the global model and review the global model. These 2 steps, if we don't have any merging to do, if we were tasked with designing the entire system for a customer, and we've already validated with them the initial system, then we don't obviously have to validate and review the global model because we've already done that. Okay. All right. All right. So you can end up with a global diagram. All right. So that's the end of that. Again, I really went through these slides fast this time because I just wanted to introduce some concepts of what we'll be discussing in 2 weeks when we come back to this. Okay. All right. So that's the logical database design. And then once we're done discussing that in 2 weeks, we will move into the physical database design, because right now, as of this point, we don't have a physical database yet. We don't have SQL statements to create tables. We're close, but we're not there. We don't have any idea. We still have not chosen a DBMS to use. We still have not done any work in deciding servers, space, any of that. That's all in the next phase. That's all in the physical database design, okay, which we'll get to after we do an in-depth discussion of the logical database design. Okay, all right. So that covers kind of the bird's eye view of the logical design and finishes up our discussion on the conceptual design. If there are, I'm assuming no questions, then we'll just go ahead and end there for today. Again, I just wanted to give you a brief introduction to the logical database design so that you could know what we're going to be discussing at the end after the midterm is finished. Okay, so I'm assuming there are no questions from the 3 of you, but if there are, I'm available, and we'll just end there for today. And other than that, I wish you well on your exams, and I'll see you guys in 1 week from today for the midterm exam. All right. Have a good rest of the day, good rest of the morning and afternoon.